Okay, welcome to our first trinomial factoring method, perfect square trinomials. Let's get started. Okay, so we're going to be working with trinomials and the perfect square pattern. Before we get started, you need to know how to use your greatest common factor and write a term as a perfect square. Example 1 should feel like review. Use the boxes below to expand the expressions x plus 4 and p minus x plus 4 squared and p minus 10 squared. So you can pause the video and restart when you're ready to compare your answers. I'm going to jump right in. So I put x and 4 outside my boxes and I multiply to fill them. My expanded expression is x squared plus 8x plus 16. For my second example, I put p and negative 10 outside my boxes, fill them in. And then I expand to get p squared minus 20p plus 100. Do you see any patterns? Okay, well, the first one is we always square the first term, x squared and p squared. The second one is that our linear term, or our second term, is the product of both unsquared terms times 2. Okay, so 8x is 4x times 2, and negative 20p is 2 times negative 10p. And then finally, we square the last term. Okay, so this pattern actually applies to all perfect square trinomials, which are the result of squaring a binomial. And we can use this to help us quickly factor trinomials of a certain type. Let's take a moment and write out our pattern. We can use this to generalize a pattern when factoring a perfect square trinomial. The trinomial a squared plus 2ab plus b squared is equal to the quantity a plus b squared. Similarly, the trinomial a squared plus minus b squared is equal to a minus b quantities squared. Okay, so notice that for both factoring patterns, both my first and last terms are perfect squares. And my middle term is 2 times the unsquared first and last term. We'll use this to determine if a trinomial is able to be factored using this method, so we'll check this requirement at the beginning of each problem. Also notice that the sign of the binomial matches the first sign of the expanded trinomial. So if your first sign of your trinomial is positive, your binomial will have a positive sign. If the first sign of your trinomial is negative, your binomial will have a negative sign. So we're going to use that to figure out which binomial to use when we're factoring. Let's try an example together. Factor the expression y squared plus 6y plus 9. I check for my GCF first, as always. Since I don't have one, I'm going to make sure that this is a perfect square trinomial. The first term is a perfect square. The last term is a perfect square. And the middle term is 2 times y times 3. So this is a perfect square trinomial. I just need to rewrite all my terms as perfect squares, my first and my last. Then I set up my binomial. Now this is, remember the signs are the same, the first two signs. So I'm just going to drop y and 3 in, and I'm finished. Let's try this one, 64u squared plus 72uv plus 81v squared. First, I check for a GCF, which I do not have. I also check, is this a perfect square trinomial? 64u squared is 8u squared, 81v squared is 9v squared, and my middle term, not quite. So our middle term is not 2 times the unsquared product of the other two terms, so we can't use this method. Okay, suppose we need to factor the expression 63n cubed minus 84n squared plus 28n. This polynomial has a GCF of 7n, so we're going to factor that out first, and then you're left with 9 squared minus 12n plus 4. I'm going to check just in my parentheses that my trinomial is a perfect square. My first term checks out, my last term checks out, my middle term checks out. So all I have to do is rewrite my first and last term as perfect squares. You may feel comfortable skipping this step at this point. You may be able to go directly into the binomial, but I just want to make sure I hit everybody where they're at. So I'm going to write my binomial. Remember, it's going to be a subtraction sign, and then I drop in 3n and 2. Don't forget to keep that 7n on the outside because we've already factored it. Okie dokie, 49a squared plus 28ab plus 4b squared. No GCF. My first term, perfect square. Last term, perfect square. Middle term, thumbs up. I'm just going to rewrite it. Okay, my first term is 7a squared. My last term is 2b squared. I'm going to make some room for my binomial plus sign and drop 7a and 2b in, and I'm done. Okay, so what was our point? So this was our first trinomial factoring method. To factor a perfect square trinomial, check your requirements, then write the first and last terms as squares, and then apply the correct formula. Now keep in mind this only applies to a certain type of trinomial. We're going to learn more about other trinomial methods in future videos. Coming up next, we have the beautiful AC method. I'll see you in the next one.